In this video, we are going to cover 8 exercises related to chapter 6. First question, which of the following arrows indicates a movement of an electron pair? Arrow A is curved arrow and it's full curved arrow. That means that it indicates movement of an electron pair. So that's the correct answer for this question. Answer B is curved half arrow or fishhook arrow. That one indicates movement of a single electron. Answer C is an equilibrium arrow. It indicates chemical equilibrium. And D is resonance arrow. It's used to show resonance or electron delocalization. And so on either side are individual resonance structures. So correct answer for question 1 is A. Question number 2. In order for a reagent to behave as a nucleophile, it must possess A and B an overall positive or negative charge. Nucleophilicity or electrophilicity of reagent is not related to charge. Degree of it may be. Something may be strong nucleophile if it carries negative charge, or strong electrophile if it carries positive charge. But charge itself really does not matter. So neither A nor B could be correct answers. C, an empty orbital. An empty orbital is feature of an electrophile. An electrophile has empty orbital. D, a free pair of electrons. Nucleophile is an electron pair donor. So by definition, nucleophile must possess a free pair of electrons. That means that correct answer for question 2 is D. Next question, which of the following is not an electrophile? An electrophile must have an empty orbital because it's an electron pair acceptor. That means that question 3 really states which of the following does not have an empty orbital. And so each of the 4 species should be examined to see which of them does not have an empty orbital. 3 of them must have empty orbitals and 1 does not. A is methyl cation, so there is empty orbital on carbon. That's obviously an electrophile. B is hydronium ion. And hydronium ion actually does not have any empty orbitals. Oxygen has its octet filled, and each of the 3 hydrogens has its duet filled. So no empty orbitals, and that means that D is correct answer. We should double check and also look at answers C and D. C is proton. Proton obviously has empty orbital. There are no electrons on proton, on hydrogen nucleus. And finally, D is aluminum hydride. There is only sextet of electrons on aluminum, which means that it's 2 electrons short of an octet, or it has 1 free orbital. So correct answer is B. Question number 4. According to Hammond's postulate, the structure of the transition state of an exothermic reaction step is similar to D. It's similar to the species closest to it in energy, and in this case, it's the starting material or reactant. So correct answer is A. B, product, would be a correct answer for an endothermic reaction. And catalyst and carbocations just don't make sense in this context. Question number 5. A forward reaction has 3 steps, with the first step being the rate determining step, the reverse reaction. And then what are the features of the reverse reaction? Well, this tests principle of microscopic reversibility, which means that reverse reaction will proceed through exactly the same steps, through exactly the same intermediates and transition states in reverse order. So reverse reaction must have 3 steps, the same way as forward reaction. That means that we can eliminate answers A and B. Among the answers C and D, C, reverse reaction has 3 steps, with the last step being rate determining. This one is correct, because if forward reaction has first step being rate determining, then reverse reaction will have last step being the rate determining, the same step in both reaction mechanisms. And of course that means that choice D is not correct. So correct choice is answer C. Question number 6. Which of the following represents a correct electron flow? Choice A has two full arrows pointing towards each other. That means that two electron pairs are moving towards each other. That's not correct, because electron pairs are negatively charged and they would repel each other. Full arrows, when representing electron flow, follow each other head to tail. That would be correct representation. B is combination of half arrow or fishhook arrow on the left and full arrow on the right. Reaction mechanism is either polar or non-polar. Polar reaction mechanism involves full arrows, electron pairs moving. Non-polar mechanism, half arrows, single electrons moving. Mechanism cannot be combination of polar and non-polar. It cannot be polar and non-polar at the same time. And that means that correct reaction mechanism should not be mixing full arrows and half arrows. For that reason, B is not correct. C has two half arrows pointing towards each other. That represents two single electrons combining to form a bond. That's correct. Half arrows either point towards each other, and as in this case, to indicate bond formation, or away from each other to indicate breaking of a bond. So this is correct. And finally, choice D has two half arrows following each other head to tail. Since half arrows represent single electrons, D is not correct. Half arrows either have to point towards each other or away from each other, as I already mentioned. Question number 7. Potassium cation is not an electrophile because A. It does not have an empty orbital. An electrophile must have an empty orbital, and so species without an empty orbital are not electrophiles. But that does not mean that that's the reason why potassium cation is not an electrophile. Actually, it does have an empty orbital. So A is not correct answer. B, it is not electron deficient. It is electron deficient. It has empty orbital, or actually it has 4 valence orbitals that are empty and positive charge. So it is certainly electron deficient. It has its octet filled. No, actually its octet is empty. So D must be correct answer. It does not form a covalent bond with the nucleophile. Potassium cation is relatively stable species because it has electronic structure of a noble gas, previous noble gas, argon, and so it is stable as it is, and it has no tendency to accept a free electron pair. So despite positive charge and empty orbitals, it has no tendency to accept a free electron pair, and that's why it is not an electrophile. And the final question, which of the following molecules or ions will react with a carbocation such as the one shown below? The carbocation shown below is secondary carbocation, secondary butyl carbocation. Carbocations are electrophiles. Electrophiles react with nucleophiles. So you can simplify this question. If this is an electrophile, then really question is which of the 4 following choices is a nucleophile, because nucleophile will react with an electrophile. A is a free radical, methyl radical. Free radicals are classified as electrophiles. Electrophiles don't react with each other, so A is not correct choice. B is molecule of water. It has oxygen with 2 free electron pairs, and oxygen is capable of donating one of those 2 free electron pairs. So molecule of water is a nucleophile, and so B is reasonable reagent that will react with carbocation. We should check C and D to see that there is no better reagent. C is boron trifluoride. Boron is electron deficient. It has sextet of electrons, 6 electrons, and an empty orbital. It's an electrophile just like carbocation. Obviously, 2 electrophiles don't react with each other, as already mentioned. And finally, D is tetramethyl aluminate anion. And that one, despite negative charge, is not a nucleophile. So, because it has no free electron pair. So it is not a good reagent to react with carbocation. So the best answer is B. And this completes Chapter 6 exercises.